Hi guys, my name is Eyal Gerber from Novodes. We're a company that provides embedded software design solutions and testing solutions for embedded software. We also provide CI/CD DevOps solutions for embedded software. And in this video, I'm going to show you a great tool that's called Lattix Architect, which helps you design the architecture for your software, and specifically, in my case, embedded software. Um, and it helps you to analyze the dependencies between your source code files and there are groups or essentially layers as you've defined them, and it helps you to enforce by defining various rules, um, this architecture on your code, um, to all those who are contributing code and updates to your code. So this is a really great tool. You can also analyze uh, let's say, the quality of your code through this tool with the use of various metrics, um, and, and essentially it also integrates with the CI/CD via the command line, and you can do a lot of stuff with this. And I'm going to just focus in this video about how to upload fresh C++ project into Lattix, and how to just get the basics, which is a lot out of this tool. Just going to show you the basics, which are very powerful in this short video. So in a previous video, I showed you how to uh, upload a project into Lattix Architect if you have Parasoft. If you're using Parasoft, C++ test, which is another great tool for static analysis or unit testing, you can, with an integration with Lattix, essentially generate dependency files and upload out the entire project to Lattix very neatly, um, and you can get the whole project there and start working with it very quickly. Um, but if you don't have that, and you want to do it without another tool, you can. And I'm going to show you how to do this in this video. And so for the first step, um, what you're going to do is click on Project, Embedded, Next, OK, and call this Testing. And you're going to choose C++ Clang. You can also, if you're using Excidian or other tools like Clockwork or Understand, I assume these tools also have plugins that enable you to upload the project for roughly straight in a straightforward manner. But in this case, if you don't have these tools, you can just use C++ Clang. And if you're using Visual Studio, that's also, I think, a pretty straightforward way to just upload the project file, get all the files here, uh, and you'll be able to get it going rather quickly. But if you don't, then I would suggest using the project configurer. And I would also set, before I choose the directory, I'll choose here DSM, which is the initial view, which is part of the things that are uh, great about Lattix, the design structure matrix. And I'll show you how it looks like and what you can do with it. And I'll also show you the conceptual architecture. I'll also generate that later. And so here I'm going to add the directory, okay, for my project with all the subdirectories included, and a filter for the C++ files, header files, etc. All right. I can choose in the options to include other standard headers, Visual Studio, whatever. Just go ahead and create project. Oh, don't know why that failed. Hold on. Interesting. Think maybe I need to include the Clang headers. Yeah. Okay. That's what I was missing. So let's continue here. Okay, so it finished now, and as you can see, it showed me about 351 errors. This took about 2 minutes, and The reason there are errors here is because obviously, this is an embedded project, embedded software project, so it's compiled using an ARM compiler in this case, not a Clang based compiler. So or C Lang, I don't know how to pronounce that. In any case, these errors, there are also not all the files that are in the folder system are used in this project. So this might be some of the reasons for the errors. Let's just click OK. Now we need to clean that up. So you don't really need to care about these errors at the moment because why they are. You know that your original project compiles and builds successfully. So I'm just going to go to the view that you can open it here. Model, views, DSM root. Okay, this is what I got. Now, this is what I meant by it's a little bit messy in the sense that it contains a lot of files that that are not originally in your project. So in my case, let's say I have unit tests. So unit tests, I can have them here. But let's say I want to clean this up. It's a different configuration of my project where I use the unit test in my actual application. I don't. So you can choose to include it here, but I'm going to delete it. Just going to click here, delete. In my project, I have here an application layer, bootloader, and other stuff. Bootloader is a different project, essentially. I don't think it should be here. So I'm also going to delete this. And I want to take out the application and the CPU hardware unit outside and separate them because they're considered here together, essentially, as part of this unit project. So how do you take them out? You click here, you do edit, cut subsystem. You can just paste it up here, edit, paste, and now it's up here. Just move it up, etc. And I can delete this one. I won't do all the cleaning here because I already did that. And what you do care about is that after you do all the cleaning, remove all the folders and files that are not that are not part of your project. Then you get a clear picture here of what's going on. And another thing you need to do is organize these folders, which represent, in my case, layers. My project was built with folders, each representing a layer. Each folder, by the way, is actually a repository. So it's a multi-repository project. It's a different issue. And essentially, so you have various folders, each representing a module or a layer, and they are interconnected, right? And you want to see it, you want to visualize your architecture here. So what does this DSM represent? This design structure matrix. It essentially tells you, let's say if I click on this one, it tells me that there is a connection between middleware and third middlewares. Okay, or let's say a different example. In this case, generated source and any drivers. Okay, drivers. So is this okay? Is this not okay? What does this mean? So essentially, if I put the mouse up here, you can see that this is the direction that it means. It says that drivers is using generated source. Okay, that's what the vertical means, because these are all the layers that drivers is using. Driver is calling out to. Okay, and in the horizontal, you see everybody that is using generated source. Okay, so in this case, there are 7 references, seven uses by drivers or calls. Let's say it could be to functions, to using variables, etc. That are in generated source. Okay, and essentially, what you want to do is define that you can structure it in a way that those whatever is horizontally most populated, you can say is essentially being used by everybody, right? So it should be at the bottom. Okay, what's least being used, okay, but calls all the rest should be at the top. Okay, so I would say that, for example, application is calling almost everybody, okay, and is almost barely used. That's why it should be here at the top. And you need to organize it in that way. And you can, use a tool that does this for you. I can do this by component, I believe, and yeah, and I think this automatically structures your DSM so that you get this structure that is automatically in a way that is by least least used to most used, uh, more or less, and you can adapt it again by using these arrows here up and down. And uh, anything that, once you've defined these the ordering of the layers, you can see visually anything that is above uh, this diagonal means that it's actually not good. Okay, it means in this case, that something that is at a higher level, okay, um, is using something that is at a lower level is using something that is in a higher level. Okay, so in this case, CPU hardware unit, okay, is using drivers. When CPU and hardware unit, you can see on this side here is below drivers. So this is wrong. This case is wrong. Anything that is above the diagonal is wrong. Unless you define it that you think that it's okay, you can make it an exception. I'll show you soon how to set rules. But I already organized this here. So I'm going to close this one, show this one here. Okay, open this up. I already organized it here. This is the true view, in this case of the project. And we said, okay, this is the view, and now we see that the problems that we have, and so one of the things you want to do is first define that everything that is above the diagonal is wrong. You want an indication for that. Okay, so you can just go here and click on. You want to set all. Click your right click, and say create layering rules. All right, bang. Everything above the diagonal now has a rule that it cannot be populated, and I want to show any violations. So I'm going to click this one, and now I see all the violations. So everything that has a number is a violation. It's marked in red. Okay, and whenever you update the source files, you can always update the project, and you see how things have improved. In any case, if I click this, I can double click it in this case, and I see the usage. I see in which file, okay, who is using what. So this file is referencing this file. Okay, so this is a violation. We have a lower layer file using a higher layer file, this one. Okay, so I can click here and I see that there's an include. Okay, meaning that that essentially this function cube main, okay, is including, okay, IPCC hardware H, okay, which is the violation. And I can see where in the source file this happens. So I can click here on the include and say view source file. And I can choose to open this in what project that I want. In this case, I'll choose understand CPP, which I have installed, and click OK. And bang, I have it and I see it here. Okay, I see the include right here. So this is cube main C, and as you can see, I'm including IPCC hardware. This is the violation, right? So it's really neat. Now, I can also click here and click on hints for removing dependency. So it can actually tell me how to remove the dependency. I'll click this, and it will tell me, all right, move following dependent subsystems to provider subsystem. Okay. All right. So I can click here, OK, and let's say So that means if I click OK, it means I'm accepting this hint, and it will automatically be moved to a task that I need to do. And the DSM will be updated as if I've done it. So I can clear the DSM even before I did the work. So I click OK and see what happens. Now I have here, under end drivers, I have here number 1. It means I have a work order. So in the work list, okay, I have a bunch of tasks to do. These are things that I cleared before. I deleted subsystems, etc. when I cleaned the DSM. So I cleaned it here. These are things as if that I need to do in the project, but I know that in this case that it's not really part of my project. I can ignore them. So this is what I'm looking for. This one that I add here. Okay. And I have this task that I need to do. I need to clear this dependency, and I'll remember how to do it for later. And this way I can go on and clear all these dependencies. I can just, I don't have to go through all of them, all of these cases. Just click here, click hint. I see all the tasks, click OK, and essentially clear every single square here above the diagonal. And then I have a list of tasks over here. I can, by the way, you can link this to Jira if you're using Jira for your tasks, and then move all your work lists to Jira. For each work list, create a task, and essentially start fixing all those problems. And you essentially resolve all your dependencies as you wanted to, and maintain a structure that you want. So that's what's great about this tool. It's really neat, really nice. Another great view here, by the way, is something called, let's see how it's called here, I forgot the name, Conceptual Architecture. Okay, so this is more of a traditional view of block diagrams. And let me show you how I already generated here. So this is like a block diagram. Click here, the usage. Okay, a block diagram view. Gonna maybe zoom out a bit so I can see everything. Okay, so a block diagram view of my entire project. And the nice thing here is I see between each block, each layer here, I see the relationships with these lines, and the red lines represent violations and according to the rules that I defined in the DSM. And I can open these and see the source files themselves, by the way. This way it's hard to see. But by the way, I forgot to show you, when I open these, I can actually see the source files. I see all the source files in the DSM. Sorry for skipping that. And I see each relationship and dependency for each single source file, and include files, header files. So it's very powerful. Again, and in this view, the block diagram view, how I call it, it's really neat. You can also, if you want to, you can expand it, open it. Again, it's really hard to see, so I wouldn't recommend doing it on the source file level, but maybe on this kind of level. It's really nice to see all the violations and open them all and trying to resolve all of them, essentially. Another view, some of you might know a tool called DOT. So DOT is something by Graphvize, an open source tool, but it has a nice integration here to create a graph subsystem with hierarchy. So this same hierarchy that we're seeing now, you can generate that from here using Graphvize. I click this, dot, system dependency, let's make it 3 layers, click OK. Open another window here. Okay. So this maybe is too intense. Sorry about that. Let's try it with not 3. Sorry, where was it? Script, graph subsystems. Let's make it 2. Okay. In this view, so again, I can see all the connections. It's nice. It's you can generate an image that you can use. It's nice. It's not perfect. I would say, but just to know you have that ability. Um, I think this view is a little bit better, obviously. And there are many other scripts and things that you can do here. I'm not going through all of the um, features of this tool, just the basic ones, and just to show you how neat and powerful this is. Um, this tool, in terms of cost, I'm not going to reveal the cost, but it's in line with tools of this kind of caliber. You would expect it's kind of pricey. Okay, so not everybody can afford it, um, and but it's definitely worth it. So uh, if you're looking for a way to manage the quality of your code, the architecture of your code, analyze everything and maintain rules and maintain the structure throughout all of your uh, developers, I think this is a great tool and I would recommend it. Um, and if this, however, is kind of pricey, uh, look forward to another video that I'm going to post soon about a tool that we developed in-house at Novodes that allows you also to analyze the various source code layers or modules as you choose to define them in your code and find dependencies. It's more lightweight, less features, but also very strong and provides a lot of value. But again, not to the extent as this one does, as Lattix. But if you're looking for something a little bit less pricey, um, and doesn't necessarily provide you with compliance support, then the Novodes tool could suffice and help you a lot. So look forward to my next video. Thank you.